by a full second. This basically turns into the number of milliseconds per tick. In a MIDI file, it's like the opposite. You get the number of ticks per millisecond. I think there are, maybe that's, I think it's like 48 ticks per millisecond. I don't care about that. I need to know how many milliseconds per tick so I can put it into my grid correctly. So what this does is it goes through the sequence, and for every track in the sequence, a MIDI file has multiple tracks. It's basically one track per instrument, not always, but almost always. That's the way it works. And I enumerate every MIDI event in that track. And like I said, a MIDI event is what turns a note on or off, or if you have MIDI hardware hooked up, it would be what toggles certain things on your MIDI hardware device that you might have hooked up. And I'm looking for a specific set of messages. The channel message tells me when a new channel begins. Channels are generally interleaved in a MIDI file. You don't get channel 1, all of its data, and then channel 2 and all of its data. You'll have whatever one starts first, and then when there's a note that happens to be in channel 2, that's when channel 2's information starts, and now it's embedded, or it's interleaved. And then whenever channel 3 or 4 starts, it just piles on, so you kind of need to keep track of which channel you're on at all times. So every time I get a channel, I add a new MIDI channel, and I'll wind up adding a new channel to my grid, a new row in my grid. So we're going to have one instrument per row in the grid as it's parsing this. There is metadata in the MIDI file, and I care about a couple of these things. I can get the track name, so I can display that in the text box, so you don't have to type the track name. And the most important thing is to get that tempo value, which is, as you saw earlier, was converting that milliseconds per tick of information. So I need to find out what the tempo is in order to divide by the proper stuff in order to get the proper timing. I believe this took like 2 weeks of mostly trial and error to get the magic numbers that make this thing work. So it does work, and that's about all I can tell you. And the second time through, so I do that, I have to look through the MIDI file once to grab all the channel information, the artist information, whatever bits I need to fill in all of my new sequence grids, so the fidget grid, so I can map the channels in one. And then I have to go through the whole thing again the second time, because now that I know the timing, I know how many channels there are, I know how long the file is, I can actually process the file. So the second time through, it does most of this, a lot of the same stuff, where it's, for every track in the MIDI file, and I'm looking for these channel messages, except this time, I'm looking for a note on command, and I find the tick in my grid that is close enough to that time, so it might start at 48 milliseconds, and I'm just going to pick 50 because I have a chunk every 50 milliseconds. So it might be a little bit fuzzy, but when you're talking sub-milliseconds like that, you can't really notice it. So I find out which place it's proper to be, and then if the note's on, I set that array index to true. Otherwise, it's set to false. There's another feature that I added called holding. There are some MIDI files, because of the way that they're written, it'll play a single note at a time, and you'll only wind up with one square on the grid. So it's going to be an instantaneous flash, which doesn't really show much, doesn't really do much. So there's a checkbox on the form that if you check this, it will hold the note until that note is turned off. So I guess the best way to describe this is like a saxophone instrument. It has a note on, but it doesn't, in the MIDI data, it doesn't hold the note until it's turned off. There's just an on here and an off here, and the sound card, it just, because it's a saxophone or whatever that instrument is, it knows that it's supposed to hold it for that length of time. So in my application, you would just see that single on. The off would be instantaneous because it doesn't know to hold it. So this way, the checkbox will hold it for that entire length of time, so you can have the light be on for that entire length of time. Then there's the handle the note off command, and once again calculate the metadata and whatever else needs to happen there. So all of this gets jammed into a sequence file. And this is stored internally in memory, and this is what it just gets serialized out basically to an XML file. I call it a .seq file, so I can load it more easily in my file load boxes. But based on which version we're saving, there's a different schema, because I've changed things with the timings and whatnot. So let's look at the save version 2, which is this one. I mean, this is just using the standard, .NET XML junk, which is, write element string. We're going to write the length of the file, the version of the file that we're on, number of channels, the fidget interface kit. These are the channels, so for each channel we know what the serial number is for that, what output port is tied to. If there's a MIDI channel involved, what MIDI channel it gets tied to. And I can actually load one of these up here. So there's just some demographic data at the top, which is where the music file is located, the total number of channels, the length of the song, and then there's one channel line per channel that you've recorded, which is going to map to a specific fidget serial number and output port on that fidget. Now, if this were a MIDI file that was originally imported, you'd also see a MIDI channel here, which is going to tie to the index in the MIDI file for whatever channel that row is responsible for. And when this gets saved and loaded by the application, so you can load a previously saved sequence, or you can save off a brand new one. Now the final, let's look at the fidget handler real quick. This is amazingly simple, and I kind of ripped this out into its own class in hopes that someday someone might write another handler for other types of hardware. There's a lot of these switching hardware things available. I'm trying to find a decent one that's USB based that will, because the downside with this, it's kind of a limiting feature, is that your lights are either on or off. You can't fade them, you can't do twinkle effects or sparkle effects, so it's a little bit boring. I mean, they can still create a decent show, but not dynamic. But there are several devices that support that sort of thing. They're generally pretty expensive. They're called like DMX light equipment, usually used in like stage productions. There are a couple of consumer level ones, but they don't have a lot of channels on them. But I've also seen a handful of other devices that support, basically toggling the voltage to the board, so you can, or to the light, so you can kind of dim them using that. So I'm hoping someday I myself or someone else will write some other handlers for that. No one has done it yet, so that's a note to you people. If you'd like to contribute, please buy some hardware and contribute. But for this handler, we just hook up to the attach and detach event, so we know when fidget boards are unplugged or plugged into the USB connectors on your PC. If they're attached, we add it to this kind of a floating global array of interface kits, which is this IF kits object right here. So when it gets attached, we shove it in there, grab the serial number so we know, and actually I think this is a hash table which maps the serial number to the actual fidget kit. So we can, using that the channel data that's saved in the XML file, we know it's, we're looking for 9217. It just indexes into the hash table, and now we're on that output for that board. So as the attach and detach to when we can add or remove devices, and it'll seamlessly do that. And then the final thing here is the sequence player.